Hey everyone, ever wanted to get inside an examiner's head? Well, today we're doing just that. We're going to take a real GCSE physics exam question and its mark scheme, pull them apart, and see exactly what makes them tick. The goal? To make sure you can grab every single mark. Let's get into it. So, take a look at this. It's a classic experiment, finding the specific heat capacity of an iron block. You've got your power supply, a joule meter, a heater, a thermometer, and the block itself. Now, this whole setup is the key to a question worth a whopping 7 marks. So we're going to break it down, piece by piece, and figure out how to claim all of them. All right, let's kick things off with the first part of the question. It's only 1 mark, but hey, every mark counts, right? These are the ones that build up your score, and it's all about really understanding why you do things in an experiment.
Okay, so here's the question itself. The student waits a bit before taking that first temperature reading. Why? I mean, what's the scientific reason for just waiting? This is a classic question about making sure your test is fair and your measurements are on point. Have a quick think. What would you write down?
And boom, here's the answer, word for word from what the AQA mark scheme is looking for. It's all about reaching something called thermal equilibrium. You just have to give the thermometer time to adjust, so it's actually measuring the temperature of the block, not its own starting temperature. It's a tiny detail that makes sure your first measurement is accurate. Just like that, 1 mark in the bag. Right, let's get into the main event, the 4-mark calculation. This is where being neat and showing all your steps is absolutely crucial. You get this right, and you're well on your way to smashing this whole question. So this is what we're working with. We have a graph that shows how the temperature changes over time. And we're also told that between 5 and 10 minutes, the energy transferred was 26,000 joules. We know the mass of the block is 2.0 kilograms. That's it. We've got everything we need to solve this. Now, here's the really interesting part, how the marks are actually given out. You get a point for each step. First, for correctly reading the temperature change off the graph. Second, for putting all the numbers into the equation in the right places. Third, for rearranging that equation correctly. And finally, for calculating the right answer. Let's walk through it together. First up, the temperature change, or delta theta. We just need to look at the graph. At 10 minutes, the temperature is 54 degrees Celsius. At 5 minutes, it's at 28 degrees Celsius. So the difference is just 54 minus 28, which gives us 26 degrees Celsius. That's our first mark. Simple as that. Okay, now for steps 2 and 3, substitution and rearrangement. We take our equation, delta E equals mc delta theta. We slot in the numbers we know, 26,000 for energy, 2.0 for mass, and that 26 we just worked out for the temperature change. Then we just need to rearrange it to get C, the specific heat capacity, on its own. This is exactly why showing your working is so important. These 2 steps alone are worth 2 marks. And finally, we just do the math. 26,000 divided by 2.0 times 26 gives us our final answer, 500. And you can't forget the units, joules per kilogram degrees Celsius. That's it. The 4th and final mark for this calculation. Nailed it. But wait, here's an amazing tip straight from the mark scheme. What if you misread the graph in step 1? Let's say you got the temperature change wrong. Here's the good news. You can still get the next 3 marks. It's called error carried forward. As long as you correctly substitute, rearrange, and calculate using your own wrong number, you still get the credit for those steps. This is a massive safety net. Okay, we're on the home stretch. We're moving on to the final part, which is worth the last 2 marks. So the student does the whole experiment again, but this time they add insulation. We need to figure out what effect this has on the results. The question is pretty straightforward. It asks what effect adding insulation has, and we just need to tick 2 correct boxes from a list of 5 choices. This is all about testing your understanding of heat transfer and what makes an experiment more accurate. And the 2 correct answers are: first, the iron block will transfer thermal energy to the surroundings at a lower rate. I mean, that's the whole point of insulation, right? And second, because less heat is being lost to the air, more of the energy from the heater is actually doing its job and raising the temperature of the block. And that means the calculated specific heat capacity will be more accurate. 2 ticks, 2 marks, job done. So, there we have it. We've completely taken apart a 7-mark question and seen exactly where every single point comes from. But what are the big lessons here? What have we actually learned about how to tackle these exams? If you want to think like an examiner, you've got to be precise. Use those scientific terms like thermal equilibrium. You have to show your working. We saw how 3 of the 4 calculation marks depended on it. You need to understand the why. like why insulation makes things more accurate. And don't forget that amazing safety net, error carried forward. It can literally save you from losing a bunch of marks over one small mistake. You see, the mark scheme isn't just a list of answers. It's a roadmap. It's a guide to thinking in the way that gets you the best possible grade. So, the real question is, now that you know how to crack the code, which question are you going to master next?